Hey, welcome back to the Rust programming language series. So this is episode 10, and in this episode we're going to explore the match expression in Rust. The match expression is similar, but it's not equal to the switch syntax in other languages. And most of this code is inspired by the Rust book. So let's jump straight into some code. Let's start off by declaring a variable. We're going to call this variable Boolean, and we're gonna set it equal to true, and then we're going to match the Boolean. So this is the new syntax right here, and then we are going to match it to false, and that's going to print line false. And then of course we're going to match it to true, and that's gonna print line true. Alright, so save that and compile, and as you can see, this prints out true, which makes sense because it's true. So if we change it to false, it's going to print out false. So what if we remove the true from right here? Well, try it. So remove it and then save and recompile, and as you can see, this says pattern true, not covered, and this is due to the fact that when you use the match syntax, you need to cover all the different patterns. So it's easy with Boolean because Boolean only has either true or false. So let's just put that true back there and then recompile. Alright, so a better example to show off the match expression is with something like an integer. So we're going to declare a number, and we're going to set it equal to 13. And then we're going to match the number, and we're going to say if it's a 1, we're going to print line 1, and if it's a 2, and then this is called a pipe right here. So if it's a 2 or a 3 or a 5, there we go, or a 7 or a 11, then we're going to print line this is a prime. And what you can also do is you can match an inclusive range. So to declare a range, you write something like, I'm going to start at 13, and then write 3 dots, and then you want to end at, for example, 19. So what are these? Well, these are teens. So the number is 18. So compile, and hopefully you'll see the error. So we haven't covered all patterns, because what if it's like 100? Well, then it's not covered. So we need to have a catch-all or a default or something like an else. And to do that, all you gotta do is put the underscore, and we'll say this number isn't covered, or yeah, something like that. So save and then recompile, and as you can see, 13 is 18, which makes sense. So what about 3? Well, 3 is a prime. So what about 100? Well, this number isn't covered in this application. Alright, so that's pretty cool, but we can do something even cooler. Well, so go back to the previous example. So I'm gonna declare a Boolean, and set it equal to true, and then I'm gonna do what's called a let match. So let binary equals to match Boolean, and then if it's false, we're going to return a 0, and if it's true, we're going to return a 1. And then we're going to print line that and something like that. And then we're just going to say Boolean binary and semicolon. Alright, so that looks pretty good, besides the fact that it's not commented. And also we gotta put a semicolon right here. So recompile that. As you can see, true is set to 1 and false is set to 0. So since all expressions result in something, this can be very, very useful. So that's what we had in episode 9. And now we are going to change this up a little bit. So first of all, we need to use what's called standard compare ordering. All right. And then we are going to change this. We're going to remove the whole if expression right here. So remove all that. And then we're going to match guess.compare. And we're going to have our secret number. So this reads out match guess.compare secret number. And if the ordering is less, we're going to print line too small. And if the ordering is greater, we're going to print line too big. And if the ordering is, there we go, equal, we are going to print line you win. And then of course we're going to break. So something like that. All right, so recompile this and let it compile and fail to remove. Just remove the target directory and try again. And guess your number. My guess is 25. That's too small. So 75. That's still too small. It's pretty nice. 90. Too small. 99 is too big. 95. I win. So that concludes this episode, and this was hopefully a fun introduction to the match expression. So good luck and happy coding.